We're going to move on to look at a second type of chromatography called column chromatography, which is used to separate and collect much larger samples. So we're going to separate and collect larger amounts of mixtures. So not when we do TLC, we're getting a tiny amount. It's great if we're trying to do something like on the forensic scale. But if we actually want to separate, say we've made a mixture of amino acids and we want to separate them out, and it's actually like 100 centimeters cubed of stuff, then we'll be able to use column chromatography because it separates larger amounts. So if we have a look at the picture, then we can figure out our stationary phase and mobile phase. So what you have is a column, looks a bit like a burette, but it's full of stuff. So we've got a tap at the bottom, and then some sort of filter paper or glass wool holding things in at the bottom, and then we fill it with our stationary phase. So silica powder, remember, is our SiO2, and then we're going to put our mixture to be separated on the top of that. Now, before we do that, we need to make sure that we've got a saturated atmosphere, and so we soak the silica powder in our moving phase before we start, so that it's full of solvent. We tip on the chemicals we want to separate, and they will start to move down. And then we pour in our moving phase on top. That's going to help push them down. Now, if the component is more soluble in the moving phase, it's going to move the fastest. So most soluble in the moving phase, and because we're going down this time, the most soluble one's the bottom one and not the top one. And the one that moves the least, so is nearest to the top this time, has the greatest retention. So let's figure out what our stationary phase is made of. Remember, we're interested in whether it's a solid, a liquid or a gas. So we've got silica powder stationary phase. Okay, so silica powder is a solid. Okay, so our column is packed with solid SiO2, silica. Okay, so it's a solid. Our phase is a solid stationary phase. You might pack it with that aluminium oxide Al2O3 as well. Our mobile phase is liquid. It's a liquid solvent. It's got a fancy name in column chromatography. It's called an eluent. You don't need to worry about that too much, but that is the name if you see that on videos. It's a liquid that our mobile phase is. And this time it moves down the column. So in TLC, it moved up the paper, up the plate. This one is moving down the column. That's important because it helps us to identify the retention and solubility differences. Right, so how do we carry it out? Now, this is not a required practical, this one. So although we've got some details here, it's not as essential as the TLC. So we fill our glass tube with the stationary phase. We held that in place with that mineral wool. Cover it all in solvent to saturate the atmosphere. And we're going to, if we've got solids, we need to dissolve our mixture to turn them into solution. And we place that mixture on top, at the top of that column. You need to run it through, but to run it through you need to open the tap, otherwise nothing's going to happen. You're just going to build up liquid, it'll flow out the top. And we time the time taken for each component to reach the end, and that is known as the retention time. And you can literally just open the tap and tap off the bottom component and then close the tap and then change to a new container, collect the next one. And the main advantage of this is you can use fairly large samples. Okay, so fairly large amounts can be separated and collected. So column chromatography, much less likely to come on your exam because there's not an awful lot for you to know. You just need to bear in mind that because we're moving down, the most soluble one will be the lowest down, whereas in TLC the most soluble one, because we were moving up, was the highest up. So we just need to be aware of those differences. Make sure you can say what the stationary phase and the moving phase are in each type.